All right, so continuing on from the last section where we looked at NumPy, which again allows us to work with sets of values that are stored in arrays of different dimensions. We're now going to look at Pandas, which sits on top of NumPy. And what this allows is for you to work with data in the form of like a data table. So these are generally known as data frames. It's was originally kind of developed from the concept of data frames in the R environment if you work with that. Another way you can think about this is similar to an Excel spreadsheet. So generally these are data where we basically have each row represents like a feature in a data set, and then each column is some information about that feature. So for example, you could have a spreadsheet of students. So each row is a student, and then you have columns which is info about the student. So like their first name, their last name, their age, their current class level, their home address, info about them, right? And what's kind of different between that type of structure and like an array is that now we can have columns that have different data types, right? So you could have a numeric column, you could have an integer column, you can have booleans, you could have text columns or strings or whatnot. Okay, so anyway, this is the next step above NumPy, which creates even more generalization about the types of data that we can read in. Okay, so again, this is really commonly used, probably one of the most commonly used Python packages. So it has its own website. It's pretty well documented. There's actually a lot of online help because a lot of people use it. So again, you kind of got to learn how to ask questions and look at other people's code to troubleshoot. But there is a lot of help available online. Okay, so first off, if you, again, want to use these, you have to make sure that you're in a Python environment that has access to Pandas or has Pandas installed. So I'm just grabbing one of my environments here I know has Pandas. Generally, when I read in Pandas, I also just read in NumPy. So that's just what I do. I don't think it's necessary, but... So anyway, I'm importing NumPy with an alias of NP, and I'm importing Pandas as PD. PD is kind of the standard alias for Pandas. Again, you don't have to do that. It just makes your code a little bit more concise. You don't have to type Pandas all the time and you're using a function or something. Okay, so if I run that, that should read in those packages. And if you don't get any error message, then that should mean that those packages work or are in the environment or available in the environment you're working in. Okay. All right, so the first thing I'm doing here is I'm just trying to create what's known as a series. So you can think of a series as basically one column of a data frame or like a spreadsheet, right? So imagine again if you had a bunch of student records, so each row is a student, so you could have something like the first name of every student, right, would be like a series. So one column with all the associated records, right? So in order to do this, I'm creating a couple different objects here. So I'm creating a list of strings, and these are just like different course names. And then I have a list of numbers, and this is the course number. And then I have a dictionary. So remember dictionaries are in curly brackets and they have like the pairing, so like the name and the value there. So basically I have this object class 1, which is the value GIS, so on and so forth. So these are base Python objects, right? We've already worked with those. And here what I'm doing is I'm converting those into a series, right? So here I convert the list into a series. Here I convert the array here. Oh, sorry, I realized this is an NumPy array, not a list, right? So because I wrap the list inside of NumPy array. So anyway, this is converting a list into a Pandas series. This is converting a NumPy array into a Pandas series, specifically a vector, one-dimensional array. And then lastly, a dictionary, right? So note that for the list and the array, I provided indexes because there aren't like names associated with each of these features. In contrast, when you have a dictionary, there is a name associated with each of these features. So I didn't have to specify that. It just went ahead and grabbed those for us, right? So if we run this, this is what we get back. So this is, again, the index here, and then or the name, and then like the associated value, right? There you go. Cool. And then just showing you how you can subset things out of an array. So out of a series. So here you were using the name, and you can use this dot notation, so dot class 3, or the bracket notation where the name is in quotes, but returns the same thing. So class 3, which was this for the S dictionary, so this one, right? So it was class 3, which was spatial analysis, right? So you'll see a lot of that.